Hi, now we are going to discuss on data pre-processing. So data pre-processing, here it is given as various steps. So first we are doing data collections. So data collection means gathering of data. So gathering of data with various sources. How you will collect data? In real time, either you can collect data or you can collect data from the sources, Kaggle or any other sources based on the applications, you will be collecting data. And next step is data cleaning. So data cleaning means sometimes you will be collecting data, so the data will be having some errors. For example, you are collecting the sensor data. So sensor data, like you are collecting temperature on a particular region. So sometimes due to that sensor errors, the temperature won't get happen in that region. So what you will do, you won't have data for that, you will be having error data. So those data need to be removed. So that is known as data cleaning. And then missing values, like as I told you that in sensor data example, sensor data won't be there, some data will be there, null values will be there in the data set, those values need to be removed. And then feature scaling, after a proper data set is formed, the proper features need to be taken from the data. So for example, in calculating student marks in a class, so what you need to do, you need only 5 subjects marks, like Tamil, maths, physics, like that, or English, like. But you don't need the age of the student, or the or any other features of the student, whether the student is height, like that, the student heights and all not needed. So these features are unnecessary features when calculating the considering the features. So you need to take only important features which is needed for calculating average marks of student, means marks only, marks of 5 subjects. So in this way you can scale the features like that. And feature, these are the feature extraction. Feature scaling means you have to make the features in a particular range. Like for example, one faculty is keeping the marks out of 200. So the student is writing exam for 200. Another faculty is keeping the test for 25 marks. The range will be in 25. Another faculty is keeping their marks for 50. The range will be 50. But when you want to calculate the average, you need to make either you can do for scale as 10 or scale as 100. All the marks should be converted in the scale of 100. So this is feature scaling. And then feature engineering, so you have to create a new features from the model to get a normal feature. And finally, if you don't have enough data, then what you will do, you will be doing data augmentations, creating a new data, creating a new data from the old data. For example, you are want to predict whether a given image is cat, like that. So you are having, assume you are having only 10 images of cat. Then what you can do, you can flip, rotate, blur, or increase the color, like that. You can do data augmentations to identify whether it is a cat or dog, like that, from the input images. So which increases you, why you are doing all those things means it is used to increase your accuracy in machine learning models. So next we will see in detail of data pre-processing. Data pre-processing is the important basic steps in machine learning. Often the real world data is incomplete, inconsistent, noisy and unstructured. So you need to clean the raw data and the meaningful data to make understand by the machine learning algorithms. Like a simple example I told you, calculating students average marks. The student average marks what you are calculating, I said one faculty is keeping exam for 200 marks, another faculty is keeping exam for 50 marks, another faculty is keeping exam for 75 marks. So these are some marks, so you need to make it as a meaningful format. So the meaningful format only data pre-processing. So data pre-processing means cleaning the data, handling missing values, so remove inconsistencies and transform the features, scaling the features and create useful features. All these things need to be done. This is the pipeline in data pre-processing: data collection, cleaning, missing value handling, feature scaling, feature engineering. If needed, you can do data augmentation, validation also you can do, and training, testing, all those things you can do. And the data collection, the process of gathering relevant information. Like I can collect the data from databases, sensors, IoT devices, websites, surveys. So websites means I'm doing social network analytics. So social network analytics, we can see the post. So some people are suddenly, if you see, you can analyze the post of some people. What is the mood of the people by seeing their post? Whether the people is very happy mood, they'll be posting very good messages, or the people are very sad or some angry mood, they'll be posting messages accordingly. So this is nothing but social network analytics. So it is very good things when you are when people are doing cyber detection, cyber analytics. So people can take their social media data and they can process it. And surveys, so surveys can be done, social media analytics can be done, and use various APIs to do the analytics. So the main important feature is you can you can predict student marks, whether. So here in this example, the student ID is 101, marks are 85%, and sorry, attendance is 85% and marks are 78, and you can see whether the study hours are 4. Similarly, if the student is studying 4 hours, 5 hours, then whether he will pass or fail. Okay, so predict diabetes of a patient by having age is 45, BMI is 28, glucose is 130, and blood pressure is 80. Similarly, another patient data. So you can collect these features, and then you can see the all these things like patient information, BMI, glucose level, blood pressure, medical history, and lifestyle factors. So by using all these things, you can predict whether whether the patient is having diabetes or not. And removing error data cleaning means here you can see duplicate the records. So John is having age 25, and John, another one, John small j, it is having age 25, and capital John is having 25. All these are same information only, so these are known as duplicate records. So are somewhere some instead of JOHN, here you can have JON or JOH, something typographical errors and incorrect values. So these things can be cleaned and made it as a proper value, which is known as John 35. And then here one more example. Here before cleaning, if you see the rupees is rupees 500, here 500, rupees 100, all are mentioning rupees 500 only. Then different values can be make it as a meaningful values, which is consistent data, which improves the model learning accuracy. And missing values, so the missing values means the people age of 25 is 50,000, 30 is null, and 28 is for 45,000. So now if I want to calculate this data, I'll be getting some errors, sensor failures, human mistake. Another again, this is also where it will tell us the missing values. Data entries are unavailable. So what is the solution? So solution is like you can remove the values, but removing the value will lead you to data loss in many rows, like that. So what you can do? So you can do a mean, calculate the mean of the value. So example, in this example, you can see this is the null value. I don't have this value. What I can do, I can add these values and find the average. Then 60,000. So that can be replaced. So why it is happening means it improves the effective normally distributed values. Similarly, median calculation. So median calculation means like 1200 is one value, 1500 is another value, 1800 is another value. So I don't have H4 some value and H5 is 25,000. So this is the outlier. This should not occur in the database. If you have this, then you won't get median values properly. So first we will see what we can do with this null value. Like you can calculate median value. So median in this data set is 1500 and 1800 divided by 2. So median is 1650. So you can add all these values and you can calculate this. Similarly, feature scaling is another example. Different features may have different range. As I told you in our marks example, each faculty is keeping marks for different ranges. How to make it as a same scale? So here you can see an example. 25% age salary is 50,000. Another person age 30 is 80,000. So here age is one scale and salary is another scale. So if you plot the graph, you can't get properly. So you need to make it as a proper range. So this will help you to work properly. So what you can do for that, you are using scaling the features. Various types of scalings are there. First we will see min max scaling. So min max scaling uses this formula x minus x min divided by x max minus x min. So here you can see for age and salary we are doing one by one. Original value of age is 25. So x, so this is the x value. 25 minus 20, x min is 25 and then x max is 30. So 30 is the maximum value. 30 minus 25, 0 by 5 is 0.00. Similarly, the 30 minus 25 is equal to 5, and then like that you can calculate. Similarly, for salary also we can calculate the values and we can plot the graph. Okay, before scaling and after scaling we can plot the before scaling. If you see, salary's scale is much larger. See, the scale of salary is in 20,000, 40,000. Okay, so it is much larger. So, but here we have made the scale as 0, 0.0, 0.5, 1.0, 1.5. So, which is a nominal range. So, it will balance the data set. So, another one scaling technique is Z-score scaling. Z is equal to x minus mu by sigma. So, here we have the values like mu is mean of variance, sigma is standard deviation. All these values you can do and you can calculate the values. So the next topic is types of feature scaling. As we saw here, min max scaling and standardization. In min max scaling will be formula is x minus min by max minus min. So x is the given value. So for age 40, the minimum value is 20. So 40 minus 20 divided by maximum wage is 60. 60 minus 20. So you have calculated values are scaled between 0 to 1. So here this is the 0, this is the 1, and you can scale. Result is 0.5 is scaled here. And standardization is Z is equal to x minus mean by standard deviation. So here if you see, mean is average. So 20 plus 40 plus 60 divided by 40. So this is the mean. So x is a given value. So given age is 20. So 20 minus 40 divided by standard deviation. How you can calculate standard deviation is the sigma. So previously we saw how you can calculate the sigma. So using that formula, it is calculated as 16.33. So divided by 16.33. This is the standardized value minus 1.22. Similarly, for the age 40, if you calculate means you are getting the answer is 0. For age of 60, you are getting the age of Z value is 1.22. So in this way, you can make it as a scaling. And then next topic is engineering. Feature engineering means like you are having the date format. 25-12-2025, but machine learning algorithms won't understand this. So you need to make a new feature like day 25, 12 and 2025. So here day is 15, month is 6, and 2025 you can make. And the overall benefits of future engineering is it will be in particular format. Here also you can say the price range is 2450. Instead that you can give some ranges 2000 to 300. Like city is Mumbai. Instead of that you can say state is Maharashtra and region is West. So West Maharashtra, like that you can say. And data augmentation is another feature. So where you can see you can improve your data set. So this is the cat image data. Here you can do rotate the image, flip the image, zoom the image, or increase and decrease brightness of the image. So this is the one feature we had initially. After augmentation you can see how many pictures. Nearly we had made 10 pictures. So similar way you can increase augmentation for image, media and text and everything. You can augment the features, so which will increase your data set and which will help you to increase the quality of the data. Various algorithms are there. Now we are going to see our concepts in supervised learning algorithms. A student studying 2 hours and marks is getting 40, and 4 hours studying getting marks are 55, and 6 hours studying students getting marks are 70, 8 hours students studying marks are 90. So similar way you can see various types. And if you see machine learning, two types are there: regression and classification. Regression is used in analytical to understand analytics. Classification is used to classify the data. Like a house you are doing 50 lakhs, and what is the price of the house, how you will predict the price of the house, or you can predict the classification, means you can classify the features. So I can use the features of predicting a house is like area. So what is the area? 1000 square feet. If the area, it is a single valued prediction. If the area is 1000, I can say it is in 40 lakhs. If the area is 1500, I can say 60 lakhs. If the area is 2000, I can say it is 80 lakhs. So it is a linear prediction model. So you are predicting the house in linear way. Similarly, you can predict with various features, multiple features. Like I can take area, bedrooms, and age of house. You can properly use all these features and you can predict the futures of the house. Okay. So next is the concept of formula for multiple linear prediction. Here y is the dependent variable, means it is means the output is dependent on all these values. So b0 is the constant term, b1, b2, b3 are coefficient, x1, x2, x3 are independent terms. Like area, I can say x1 is an area, x2 is the bedroom, x3 is the age. So all these are independent variables. So this y is the dependent variable. By using this formula y, you can get this dependent variables and you can get the output like this. So, and one more thing is polynomial regression. So polynomial regression, sometimes you can't able to make the things linearly. You will be having in curved form, non-linear. So in that case, you can say it won't fit in a single straight line. Like predicting the salary and all, we can say 25 means the salary is 30,000, like that we can say. But some cases you can't fit in this problem. So those problems can be come in polynomial regression problems. So for example, I can say advertising. So if a customer is advertising, a company people is advertising for 5 minutes, means whether he can see how the customers are buying. 5 minutes advertisement, the customers will buy for 10,000 customers will buy. It can't fit in like that. So it based on the interest, it should come. So those places and all, we can say it is a polynomial regression. Okay. And similarly, one more regression is logistic regression, which is based on probability value. So probability value, whether a student passing or fail, output is logistics. By keeping the probability value, he will say less than 0.5 means he will fail. The probability greater than 0.5 means he will pass. So using the probability function, you can predict. Similarly, naive based classification, we already saw example of probability based theorem. So like that, you can see you can calculate posterior probabilities, useful evidence minus by total evidence, you can predict the value. So similar way, one more algorithm is k nearest neighbor algorithm. So k nearest neighbor algorithm, by it will predict the new fruit. Given the input as apple and orange, if you are giving a new fruit, means it can't able to predict. Either if you give apple, means here it can say it is an apple, like that. K nearest neighbor problem is the next topic is classification. So classification means, as I told you, like here you classify properly, it should classify whether it is pen or pencil, dog or cat, like that it is a classification. So for that, the best things are decision trees. So decision trees, like it will how whether the loan can be approved for a particular age, a particular customer. So based on this decision tree, you can predict it by CIBIL score, salary, everything you can see, and it can be predicted. One more thing is random forest algorithms. Random forest algorithms are very good algorithms which will give you high accuracy, less overfitting, and robust predictions. Another one is unsupervised learning. In unsupervised learning, you don't know anything about the input, and you will be discovering or exploring on the data sets. So, like customer segmentation, market basket analysis, anomaly detection, all these things are coming under unsupervised learning. In next video lecture, we will see more in depth about unsupervised learning. I hope you understand this. Thank you.